Hello all. In this lecture we are about to discuss the different types of proximity sensors. The first one being the eddy current proximity sensors. The eddy current proximity sensors detect the proximity or presence of a target by sensing the magnetic field generated by a reference coil. Eddy current sensors detect ferrous and non-ferrous metals. They can be used as proximity sensors to detect the presence of a target or can be configured to measure the position or displacement of a target. So, an eddy current is a local electric current which is induced in a conductive material by the magnetic field produced by the sensor or the active coil. So, this will be sensed by a reference coil to create an output signal. So, whenever the distance between the target and the probe changes, the impedance of the coil changes accordingly. This change in impedance can be detected by a carefully arranged bridge circuit. So, it can be used for non-magnetic but should be a conductive material. So here if a coil is supplied with an alternating current, an alternating magnetic field is produced. If there is a metal object in close proximity to this alternating magnetic field, then eddy current will be induced in it. These eddy currents themselves produce a magnetic field. So this distortion of the magnetic field responsible for their production. So as a result, the impedance of the coil changes and so the amplitude of the alternate current also changes. So at some preset level, the change can be used to trigger a switch. So here you can see that it is provided with an amplitude detecting circuit and an output circuit. So they have the advantage of being relatively inexpensive, small in size, with high reliability and can have high sensitivity to small displacements. Coming to the application of eddy current proximity sensors, it is used in places where automation requires precise location, then in machine tool monitoring, then for final assembly of precision equipment such as disk drives, measuring of dynamics of a continuously moving target, then drive shaft monitoring and vibration measurements. The next one is going to be the inductive proximity sensor. So it consists of a coil wound on a core. When the end of the coil is close to a metal object, it induces a change. This change can be monitored by its effect on a resonant circuit to trigger a switch. It can only be used for detection of metal objects and is best with ferrous metals. So here an inductive proximity sensor has four components. The first one is the induction coil. Then you have a oscillator, a detection circuit and an output circuit. The oscillator generates a fluctuating magnetic field around the winding of the coil. So that is going to locate the device sensing phase. When a metal object moves into the magnetic field of detection, eddy currents build up in the metallic objects and these eddy currents produce a secondary magnetic field that interacts with the field of the probe, thereby loading the probe oscillator. So if no object is in the no object is in front of the sensing phase, then there will not be any loading for the probe oscillator. So whenever an object is there, there is going to be a loading of the probe oscillator. So the effective impedance of the probe coil changes, resulting in an oscillator frequency shift, or there is going to be an amplitude change. The sensor's detection circuit monitors the oscillator strength and triggers an output signal from the output circuitry proportional to the sensed gap between the probe and the target. The application of these inductive proximity sensors are industrial automation, counting of products during production or transfer, then in the case of security for detection of metal objects, arms, then landmines. In all these cases, inductive proximity sensors can be used. So the next one being the capacitive proximity sensors. So here the inductive sensors which use the induced magnetic field to sense objects. So here the capacity proximity sensors will generate an electrostatic field and reacts to changes in capacitance caused when a target enters the electrostatic field. So when the target is outside the electrostatic field, the oscillator is going to be inactive. Whenever the target is approaching, a capacity coupling will be developing between the target and the capacitive probe. So whenever this capacitance is going to reach a specific threshold, the oscillator is activated. So that is going to determine the range of this capacity proximity sensor. So once this threshold value is reached, it is going to trigger an output circuit and it will be changing the state between on and off condition. So here the ability of the sensor to detect the target is determined by the target size, then the dielectric constant and distance from the sensor. So if the size of the target is going to be larger, there is going to be stronger capacity coupling between the probe and the target. Materials with higher dielectric constant are easier to detect than those with lower values. The shorter the distance between the target and the probe, the shorter is going to be the capacity coupling between the probe and the target. So this is the figure of the capacity proximity sensor. So you can see that similar to the other sensor, here also it has got 4 units. One is going to be the facing surface of the proximity sensor, which will be having a sensor electrode and two compensator electrodes, which is going to be the in the case of unshielded sensors. Next is going to be the oscillator. Then you have got a triggering circuit, and next is going to be the output. The front view of the sensor is also shown here. So how the field is being generated, it is also shown in the figure. The next one is going to be the ultrasonic proximity sensor. So these ultrasonic sensors generate a high frequency sound waves and evaluate the echo which is received back by the sensor. So you are provided with a control circuitry which will be measuring the time interval between sending the signal and receiving the echo to determine the distance of an object. So passive ultrasonic sensors are basically your microphones that will detect the ultrasonic noise which is present under certain condition. So all these ultrasonic proximity sensors will be using a piezoelectric transducer to send and detect the sound waves. These transducer will generate high frequency sound waves and it will be evaluating the echo by the detector, which is received back from the reflecting target. So the sensors will be calculating the time interval between sending the signal and receiving the echo to determine the distance of the target. So if there is no target in its vicinity, then it is not going to reflect the sound. So whenever the target enters the operating range, the output will be switched on. Now in most of the cases, these ultrasonic proximity sensors will be equipped with temperature sensors and a compensation circuit in order to enable the compensation for changes in operating distance caused by temperature fluctuations. And these sensors can work in diffuse reflex or true beam mode. So here this is the figure of the ultrasonic sensor. The first one is going to be the true mode. You can see that emitter is in one place and detector is on the other side. So whenever a target is entering in between the two, emitter and the detector, it is going to say that an object is coming in its path. But in the case of ultrasonic proximity sensor, the second mode is normally used. That is, the emitter and detector are provided on the same side itself. So here the emitter will be sending in the waves and the detector will be detecting the waves. So the time taken from the emitter and the receiver will determine the location of the target. So if it is within some specified range, then the sensor will give an indication. The last one is going to be the optical proximity sensor. So these optical proximity sensors are also known as light beam sensors. So it is going to be a solid state LED, light emitting diode, which is going to act as a transmitter by generating a light beam. On the other side, you have got a solid state photodiode which is going to act as a receiver. So the field of operation of the sensor is going to be a long pencil-like volume formed due to intersection of cones of light from the source and the detector. So any reflective surface that intersects the volume gets illuminated by the source and it is seen by the receiver. So generally a binary signal will be generated when the received light intensity exceeds a threshold value. So this can also be used to find out the nearness of an object. The application of these optical proximity sensors are fluid level control, then breakage and jam detection, then stack height control, box counting, etc. Thank you.